Hello, class. Welcome to Chapter 9. This is 9b, Hypothesis Testing of One Population. We are continuing with the idea of hypothesis testing. In the previous section, or lecture, we were able to understand the basics of hypothesis testing. So now we are ready to go ahead and do a complete test. So I want to start with the example we did last time, and I want to do a thorough step-by-step process of the testing. So testing a claim about a proportion. So let's call upon this example we used. 1,009 consumers were asked if they are comfortable with having drones deliver their purchases, and 54% or 545 of them responded no. Test the claim that the majority of consumers are not comfortable with drone deliveries. Okay. So we'll start with step 1. So I will save all the explanation because we already took care of that. So we'll go straight into these steps. Step 1 was about identifying the claim. So let's write there. Identify the claim. Okay. And the claim was majority of consumers are not comfortable with drone delivery. Then step 2 says symbolic form. Write this in symbolic form. For that, we identify what this is about. Is this claim about a mean, or is this about a proportion? So we already discussed that. So this was a claim about the proportion, and this claim is about the population proportion. So P is majority means more than 50%, so 0.5. So P is greater than 0.5, 50, which is 0.5. Okay. Then we have step 3. Identify null and alternative hypothesis. So we have H0 is always the equals. So P equals 0.5. It's always coming from your claim, okay? P equals 0.5. Let's make sure that this always has the equals. And the other one, H1, which is the alternative hypothesis, will be this claim. Because it has to contain the inequality symbol, you know that this is the claim. I ask you to immediately identify the claim, whether the claim sits in H0 or if it sits in H1. If you recall from the lesson last lecture, we did have the conclusion statements, right, for step 8, where we had to come back and see where the claim was sitting. Was the claim sitting in H0 or H1 in order to make those conclusions? So if you make that clear right here in the beginning, that really helps you to put all these things together quickly without confusion. Okay. Step 4. Select significance level, right? So significance level. Now, most problems give you the level. If they don't give you the level, you're free to use your alpha as 0.05, okay? So I'm going to use alpha as 0.05. So I'll say commonly used value. If it's not given to you in the problem, you're free to use this commonly used value. Okay. Then we use the step 5 is the test statistic. For that, we quickly look at the table we used for the test statistic. So if it's proportion, we only have this first row to worry about. So because this is proportion, we know the sampling distribution is normal, and we have to check these requirements, and then we'll use the test statistic. Okay, so I'm going to quickly write these things over there. So we found that this is to do with proportions, which implies normal distribution. And for that, we have to use the check. So I can take you quickly to the check. I mean the requirements. NP must be greater than or equal to 5, and NQ must be greater than or equal to 5. Remember again, this proportion is to do with binomials, right? So all the binomial conditions must be satisfied. That's why NP must be greater than. We said there must be at least 5 successes, right? Greater than or equal to 5. NQ, I mean, repeated the same thing. So these would be your requirements. Okay, so quickly identify your N. N is 1009. P is 0.54. P is 0.5, and go ahead and multiply them. And Q also is 0.5. Remember, P is 0.5. P hat would have been 0.54. So N times P, you can already see that it's going to be, that it's going to work. Nevertheless, I do have a calculator by the side, so I am doing the calculation. It's a good idea for you to pause and do the calculation itself. It's 504.5. Well, we're just looking at the requirements, so this is greater than or equal to 5, so that's good. And Q is also 0.5, so you're going to get the same value. So the checks are all working out fine. So then we are now ready to go ahead and find the test statistic. In fact, we did this in the last lecture, but I'm going to do that here just so that for continuity. So we know that, let me quickly take you here. So we wrote proportion P, normal Z, and P greater than 5, and Q greater than 5. Now it's time to use the test statistic. All these worked, and so that is the formula you want to use. Z is P hat minus P over square root of PQ over M. Okay. And collect all your values. So P hat is 0.54, or remember we did the ratio, the fraction, X over N. So that's something you can use as well. Okay. If they didn't give you the percentage right away, if they just told you the number of people who answered no, then you would write the X over N format to get your P hat. P is 0.5. Q is also 0.5 because it's 1 minus P. And N is 1009. Plug them in. 0.54 minus 0.5. 1009. And this came out to be 2.54. If you're using technology, you might get, probably 2.55. Or if you were using the entire thing, like 545 over 1009, if you kept it as a fraction instead of 0.54 here, right? So if this was rewritten as a fraction, then that effect would give an answer as 2.55. It's not so different, but sometimes it may make a difference if your when you do the critical value, it was that close. So just letting you know that rounding can have impact in your calculations. So that is your step. What was it? 5, and then you go to step 6. And here it branches into two types, right? So let's do, we did the critical method, critical value method. So according to this method, we have to identify what tail it is. Is it one-tailed or two-tailed, right? And for that, we looked at H1. Okay. So I'll just say determine if two left or right-tailed test. Okay. To do that, your focus is on H1. So H1 in our problem uses greater than. This implies we are using right-tailed test. Okay. Let's draw the, for this you have to draw the graph to get the region. This is your mean. And we used alpha. Alpha is how you determine the region. So alpha is the 0.05. So you're shading the 0.05 area. What is different from the critical value we learned in the confidence interval lesson was that there it was Z alpha over 2. So you divided that alpha value into both the tails. Here, when we say right-tailed test, all of that alpha falls in that right tail. So this entire space here, this region here, itself is 0.05, okay, or 5%. Therefore, that is how you know that this is the critical value that separates that area, right? So you're trying to find this critical value, which is Z, okay? So remember that critical value Z, for which you're using the Z table, again, for the purpose of this online lesson, I'm using the tables to find these values. Now, if it's 0.05, your table value gives you the cumulative area from the left. So because of that, your cumulative area from the left up to Z, right? Because Z is the border line that separates it. So that cumulative area must be 1 minus 0.05. That area comes to be 0.95. So area is 0.95, right? For which you have to go to the table. In fact, we did that. So we have that left over from last lecture. So I'll just use that. So 0.95, you go to the body of the table. The body of the table is where the four decimal places, right? You see all those values with 4 decimal places. That is what I mean by the body of the table. The body of the table contains the area. So you're looking for the area that matches up with the value 0.95. And what I've highlighted here is the value that comes close to 0.95. It's not exactly 0.95, it's 0.9505. So there is a slight overestimate here. So you look at the corresponding Z values, and that gives you 1.6 from here and 0.05, so 1.65. Okay. Now, if you're using technology, or if you're using existing tables that gives you these values already, if you are searching it on the net, also in some books it can give you that. That could give you 3 decimal places. So the critical value is 1.645. I'm going to use that as the critical value here. So this is from the table 1.645. The table gave us 1.65, but I'm using 1.645, which is a more accurate value for the area 0.95. So this is the critical value here, right? Z. Okay. That is your Z, I mean, that's your critical value method from which you found the region and the Z value. I'll go ahead and do the other method before we go to step 7. So say or p-value method. This again, we mostly use technology for this, but you're free to use the table also for this. So for this, we have to go to step 5. So step 5 gave us Z as 2.54. Let me quickly check that. Yes, 2.54 or 2.55, depending on what you had. Okay. And this was a right-tailed test. So once again, if you draw the graph, and your right tail was marked off at 0.05. Right? And now we have the Z value is 2.54, which is your test statistic. Let me write here. So let me mark Z. Okay. So Z is 2.54. So I'll say go to the table to locate the area, right, that corresponds to Z equals 2.54. Right. So then we go to the table, 2.54. So these are different marking tools. So 2 point, use blue perhaps, it's light. 2.5, 2.54, or if it is 0.5, 2.55, then you're going to look at that column. Look at the value that corresponds to it. It could be either this or this, right? Because we had the table, because we did the 2.54, I'll stick to this. 2.54 is 0.9945. 0.9945. Let's take that here. That area corresponds to 0.9954. That is 99%. So clearly you can see that I'm going to kind of remove the 0.005 because we just wanted the right-tailed. So 0.9954 is the area, the cumulative area. This corresponds to the cumulative area to the left of this Z equals 2.54, right? Of Z equals 2.54. But we know that we got the right-tailed test. We need to do the right-tailed test. So you want this area here, right? So this area here is not 0.05 because this area is going to be adjusted based on this Z value. So Z value, so here you first find the Z value and then find the area. In the critical method, you had the area and from that you found the Z value, right? So here we go. We got the 0.9954. So to find the right shaded area, we do 1 minus 0.9954. So this will give us, again, use your calculator, 1 minus 0.9954 gives us 0.0046. Okay. So this blue shaded region would be 0.0046. Okay. Let me come down here and say p value that you found is 0.0046. Okay. So quickly, for your critical method, you had the area already from your alpha as 0.05. From that, you used the body of the table to find the corresponding z-score. Okay. In p-value method, you use the z-value from step 5, the test statistic, and you use that in the table to find the corresponding area. And we had to do a little calculation there because the area that the table gives us is cumulative area from the left. We had to consider the right tail test and do the 1 minus that cumulative area. And that area value is the probability, right? Area is the probability. So your p-value itself is the area. So I'll just write here, probability equals the area. So the shaded area is the probability, and your p-value is 0.040046. Now we go to step 7, is make a decision. So for this, I'm going to create 2 columns. Critical value and the p-value. Critical value and the p-value. So now we can go ahead and use the information that we had for the critical value. Remember again, there are, what do I say, criteria or conditions that we will use to test if you will reject H0 or fail to reject H0, right? So we'll just remember that. So if we were to reject H0, the condition said, if the test statistic is in the critical region, then we will reject H0. So let's come back here. Again, for clarity, I'm going to draw the graph again, but you can always go back to the graph that you used, so we don't have to draw it multiple times. But remember again, for critical value, your alpha was your shaded region. Once we decided right-tailed or left-tailed, your alpha was in the critical region, was the critical region. So alpha is, this was 0.05, which is your alpha. And we got the z to be 1.645. Okay. Now it says, take your test statistic, right? Test statistic, which is step 5. So write that here. Test statistic comes from step 5. And that z was 2.54. And we have to see where that 2.54 lies. So, this is your 0. So z equals 2.54 lies in this spot. Since your test statistic lies in the blue shaded region, we reject H0. That's the decision we make. We reject H0 since z equals 2.54 lies in the rejection region. The rejection region is the blue shaded region here, right? Then come to p-value. P-value is more a comparison of numbers, so you don't have to draw this, right? So let's just quickly note down what the p-value was. P-value came out to be 0.0046. And alpha is 0.05. And we have to compare p-value and alpha and see how they line up. So the rule says p-value on the left and alpha on the right. Okay, so p-value is 0.0046, because if you switch the order, you'll be interpreting it differently, right? So we need to see what sign you should place in between p-value and alpha. So p-value is less than alpha, right? 0.0046. So this is less than alpha. So that condition implies that we reject H0 since p-value is less than alpha. If your p-value is exactly equal to alpha, we will still reject it because that's what the condition says. But if the p-value is greater than alpha, then we fail to reject H0. So be very clear about what the condition says. The condition is it's holding true in both. The decision is holding true in both these cases because we used equivalent methods, so we reject H0 as the decision for the methods we used on step 6. So step 7, the decision is made, we reject H0. Then we go to step 8. Restate the decision. No one outside the statistics world will understand reject H0, right? So we have to write it in a language that people can understand. And so if you remember, we went back to that conclusion table. So you have 4 ways you can conclude it, depending on how your values are sitting. So here we have to decide first 2 things, whether the claim sits in H0 or the claim sits in H1. Okay. So for our current problem, reject H0 is established, right? We have to reject H0. So that is these 2 conditions. The other 2 will fail to reject H0. So these are the two conditions between which we have to consider. So if my claim is in H0, I use the third condition. If it's in H1, I use the first condition. So quickly go back here. Where does our claim reside? We took care of that right when we built step 3. So you can see that your claim is in H1. Your claim resides in H1. So you know that you have to use the condition related to the first row. Okay. So you're going to use this language. Okay. So I'm going to come back here and say, since our claim is in H1 and we reject H0, these 2, okay, claim in H1 and reject H0, these 2 conditions implies that we have to use this language. Let me check the language quickly. There is sufficient evidence to support the claim that, let's come back here. There is sufficient evidence that, and then you will have to insert the context, okay? That, insert the claim, okay? So I'll just say insert claim here. And then I'm going to continue. So the claim here was that the majority of the consumers were not comfortable with drone delivery. Okay. So the claim, is, so we have sufficient evidence to support the claim. So we're supporting the claim that the majority of the consumers were not comfortable with drone delivery. I hope you kind of enjoyed how we did it systematically, step by step, to arrive at this conclusion, right? Now let's look at an example related to mean. Okay. So I'll say testing a claim about a mean. And I'm going to copy the question. So here's the problem. A common recommendation is that adults should sleep between 7 hours and 9 hours each night. Use a 0.05 significance level to test the claim that the mean amount of sleep for adults is less than 7 hours. And you have the data values given to you. These are the number of hours. So go ahead and count what you have. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. You only have 12. The n is 12. So keep that in mind. And here you are given the raw data. So you'll have to compute all these things. All right, let's begin with identifying what this is about. This is clearly talking about the claim. So, it's to do with testing of hypothesis. And there you have two parts. Is it testing about a claim about a proportion, or is it a claim about a mean? So for that, again, you have the hint. It says the mean amount of sleep time for adults. So, it's testing a hypothesis for a claim about the mean. So that's good. So in your mind, you must now think mu. Okay. The mean here would be the mu, because it's about the population mean. All right. Once you have these things, before you begin testing, remember we have to make sure that the requirements are met. So check requirements. For proportion, the requirements were related to binomial, right? Here we have to check if it's SRS. Again, we will give a right on that because this data actually was obtained from one of the studies, the National Health and Nutrition Examination Study. You don't have that information given to you. I have that at my end, so sorry about that. So we have that. So we got the SRS. And 2, the population should be normally distributed, or N must be greater than 30. Population must be normal, or N is greater than 30. So N is not, there is no information about N. All we are told is these are randomly selected adult subjects. We are not told if it is the population is normal or not. So we do not have information on that. Unfortunately, we don't have that. And if you look at N counts to be 12. So that also is a no. So when you have both of them failing, we do have a backup last ditch effort, which is your normality test. In fact, you could also use histogram. Remember histograms? Because we didn't do the normality test, the lesson in detail. So the normality test, I recommend that you use a software to get things done, or you could use your calculator for that. And look up a tutorial for that, and that should be fine. If not, we've done histogram. So you could also look at histogram and see if you can see a roughly bell-shaped curve on the tops of the bars. Okay. So for convenience, I have presented to you the information. Again, for homework purposes, you would not be asked to do this, but this is for real life purposes. If you were to conduct this, you have to always make sure that these conditions are satisfied. But for homework, we'll try to give you N more than 30 so that you have a way of calculating it. And if it's not more than 30, we'll try to give you the information that it came from a normal population so that you are not really called to do this background work. But anyways, here it is. So your histogram is X values in the frequency, right? So it's roughly a normal distribution, so it's not too deviating. And if you also look at the normal quantile plot, which is the normality test, so it is X values versus the Z score, right? We saw this in confidence interval chapter in that video. So if you want to check back on that, you could do that too. So we plot these blue points, and then we use the trend line to see if you can draw a line that passes through most of these points. And you have the green line that indicates that that is the trend line. So you can fairly say whether this appears normal or not, and we are able to say that this is approximately normal distribution. So normality test, histogram test, these two pass. Therefore, the requirements are satisfied. Now we can move on to our steps. Step 1. I'm not going to write what that step is, so we'll directly write the result for that step. Step 1 is to write the claim. The claim is mean amount of sleep for adults is less than. mean amount. So remove all the clutter and just write what you need to translate into the symbolic form. Mean amount of sleep is less than 7 hours. Okay. Step 2, translated. So mean amount is the population mean, so mu is less than 7. Less than simply means less than. So very, very straightforward. Step 3. So quickly, let me write that this is the claim, right? This is the claim in words and then in symbol. And your H0 is always your mu equals 7, right? So H1 then would be the claim with the inequality. And again, directly note that this is your claim. We're going to need this when we do the decision. Right? Step 4. Alpha. So alpha is given to us in this problem as 0.05. If it was not given, we would still have used, 0.05. Step 5. We want to go back and see if we have to use. Remember this table? If mu is what you're trying to um, find the claim about, then you have two possibilities that it can be a t or a normal distribution. You have the formula. So because we are given the data, we have no problem using this formula, t equals x bar minus mu over s over root n. So we're going to use t distribution. And the formula is t equals x bar minus mu over s over root n. This is the formula given to us. But where is x bar, where is s, we have the mu and the n. So x bar and s is going to come from plugging in these values in the list in your calculator using stat to find all the values for that. Okay, so x bar and s, we're going to find that using in stat 1 bar variance. That will give you the x bar and all that, right? So let's come down here and I make a quick note about it. Use the raw data. Yeah, to do calculator. Enter list, right? L1, L2, remember that? And then you will go to stat, calc. You could do this manually, but it's going to take forever. Okay, so you will use the calculator on this. 1 bar stats. This was stuff we did early in the course, so please recall that. And that will give you follow the directions after that. It'll say list L1, frequency list, calculate. So go ahead and if your data values reside in L1, then you're good. If your L1 is already used by other data values, either clear it and put the new data there for this problem, or go to another blank list and use that list and call upon that list when you do the calculations. All right, so go there and you would use the information there. And I did that at my end, and I found blue for this. I found x bar to be 6.833333, right? And then the s came out to be 1.99240,984. Okay. The n must show us 12, of course. Remember there is sigma x and there is sx in your calculator. Make sure you're using the right notation. Okay, take those values and plug them in. Please do not round them prematurely. So it's okay if you had to enter this long number. Mu is 7 because that comes from, let me also write that here. Mu is 7, that comes from your plane. You're not calculating that, that's coming from the plane. Over S over root n. This is your TLT, central limit theorem formula, where mu x bar is the same as mu, and sigma x bar is the same as sigma over root m. In this case, sigma is unknown, so we use S. That's the beauty of using the t-test, the t-distribution. Okay, 1.99240,984 over square root of 12. Again, use your calculator. We can clearly see it's going to be a negative answer because you got 6.8 minus a 7. So it's going to be a negative answer. And that comes out to be negative 0.290. Okay? And this is a place where you could round it. Okay, this is where you will round. Now you could use technology for the next step to use the p-value. Right? If you're using technology, then you want to go to the t-test. Okay, so let me, again, it's hard for me to show you from the calculator. So your value would be drawn from the table if it is easy to find the table value, because what happens with the t-test is, let me show you the table here quickly. What happens with the t-test is you're using this table, right? Now look at the degrees of freedom, because you will use the t-test corresponding to the degrees of freedom, and our n is 12, so you have 11. So in this problem, it is kind of okay, right? We are able to still use the table. Now, what if your n was, let's say, 45? Okay, 45. So n minus 1 would be 44, and there is no entry for 44. So those are the times when we find that technology is superior in handling these kind of issues for us. Yeah. So so p-value could be done using technology. Okay. So I'm going to kind of verbally direct you, but we'll just put the pertinent details here. Okay. Now you have your data already entered in your calculator, and you have that information, right? So what you could do is now go in. So this is for your calculator. So just say, and what was this? TI-84. If you had a different calculator, of course, use a tutorial, a corresponding tutorial to help you guide through this. So what, if it's TI-84, what you do is click on Start, then go across to the tests. And again, your assignments also will give you directions on this. And the ebook also gives you directions here. So there are plenty of places to get this information. So go across to the tests. You have the edit, the calc, and then so go to the tests, and then go down to number 2, which is t-test. Hit enter, and then it gives you 2 options. It should give you, again, TI-84 gives 2 options. One is data, the other one is stats. So since you have the data already, in the input, so use the data. If data was not given to you, you will have to enter stats, meaning you'll have to physically enter the values. Right now, the data will take care of everything. Again, for exercise purposes, I want you to try both of them. Okay, try pulling it from the data to see how this fills in. But if you're using the stats, I'll kind of show you what that looks like here. Okay, so you have something that looks like mu naught. Mu naught is your mu. Okay, the plane, you see up here, plane. So enter 7 there. If you're doing the stats version, you're entering the summary statistics. So you will enter the values manually. So in this case, you would have entered X bar as 6.83333, right? And then SX is the next field. For that, you will enter 1.9, is it 99? Yes, 1.99240,984, right? What we have up there. And your N, it will be 12. And then it gives you 2 or 3 options. It says mu is not equal to mu naught, less than mu naught, greater than mu naught. So you obviously will choose the less than mu naught, because mu is less than 7. You set mu naught to be 7. So the claim was mu is less than 7, right? You got that? And then you will hit calculate. Okay, once you enter all these things, hit calculate. Now test it again with the data, because then you don't have to enter them manually. You can call upon the data. All right, so once you do all that, you'll have a display of all the values. The display will show things like this. Mu is less than 7. T is negative 0.28977491113. P is 0.3886888243. X bar comes out as 6.833, the one that you entered, so it should not be any different. SX is given to be 1.99240,984. Now, if you use the data, this is kind of helpful to see if the X bar and the SX all match correctly, so that you called upon the correct data list. Right? This kind of helps as an inbuilt check. But here is the important stuff. You said we're using technology to find the p-value. So this is the p-value we are interested in. Okay. In fact, if you look at the t-value, it also gives you the t-value. So we didn't have to calculate it manually. That's your t-value there, the test statistic, I mean, that we manually calculated in step 5. That can be derived right here. And this is your p-value. You can safely round it to 4 decimal places, 0.3887. Okay. For the purpose of this lesson, I'm just going to go with p-value method. But if you wanted the critical region, that's also fine. You can use the t-table, use 11 as your degrees of freedom, right? And then use alpha 0.05 to find area in one tail. We'll come to that. That this is p-value. Now tell me what this would be. Is this one-tailed, left-tailed, right-tailed, or two-tailed? So for that, we go to H1, right? Okay. So H1 uses less than, which implies it must be left-tailed. If you're drawing your graph, you are shading the left region. So this is for p-value method, right? You're shading the left region, and then we just found that p-value to be what directly? To be this computed value, 0.3887. That's what we have. And where it happens is also given to us, right? T is negative 0.289. Excuse me. That makes sense because you're looking at the left tail, so it must be a negative t, and then you have so they all line up. That's really nice. You can see them all making sense together here. All right, so then you use the left-tailed test, and so all these are taken care of in technology. If you're using the critical value, okay, then you once again determine it's left-tailed, right? And what happens there is, it's left tail, but we know that the left tail is that 0.05. Okay. Your alpha. The approach is with let me reiterate again in this section, that with p-value, you use the test statistic and then use the table to find the p-value, or you could use technology to get that answer right away, right? But in critical value, we first use the area, we use alpha, and then find the t-value. So in p-value, you use t to find area. Here we use area to find t. Okay? So the t here, for that you have to go to the table, and the degrees of freedom is 11, okay, 1 minus the 12, so 11. And then look for one-tailed test, so that's one tail. And for one-tailed, you have 0.05 for one tail, right? So for your 11, it's 1.796. Okay. Because it's left-tailed, it has to be negative 1.796. Negative 1.796. That's something we have to adjust because it's left-tailed. It has to definitely be the negative quantity. So that's what we have. And then we come back to the test statistic. The test statistic was negative 0.289. Okay. So look at the test statistic and see where it falls. Negative 0.29, right? Negative 0.29. Test statistic is negative 0.289 something. That value lies outside the rejection region. That's where it lies. So we hold on to that because we're going to now go to step 7 to make the decision. So you can choose any one method, and they are equivalent, so they will have to give us the same information. So for because we use the p-value first, the p-value method first, let me do the decision for that. Remember, for the p-value method, you set your p-value on the left and your alpha on the right. So write the p-value, which was 0.3887, and your alpha 0.05. See what sign should go in between them. Very clearly, we see that your 0.3887 is bigger than the alpha value. So we say fail to reject H0 since p-value was greater than alpha. Okay. And for the critical value method, we fail to reject H0 since the test statistic lies outside the critical region, outside the shaded region. Yeah. So we made our decision. Now it's time to make the conclusions. Step 8. For the conclusion, I have to see where my claim resides. So I'll go back here. Claim is H1, okay, from step 3. Claim is in H1. This comes from, oops, what happened to the claim? Claim is in H1. And this comes from step 3. And the decision was failed to reject H0. This information comes from step 7. Use these two to make your conclusion. So let's go to the conclusion table. Okay. Claim is an H1 and we fail to reject H0. So we're looking at the second row. That's the condition it satisfies, the second row. And so the conclusion is there is not sufficient evidence to support the claim. Come down here. There is not sufficient evidence to support the claim that, and then insert the language from here, okay? So what was the claim? The claim was that, go back to the question, okay? Take you back to the question. The claim that the mean amount of sleep for adults is less than 7 hours. Pull that statement and insert it there, okay? The mean amount of sleep for adults is less than 7 hours. Yeah. Let me read that again. There is not sufficient evidence to support the claim that the mean amount of sleep for adults is less than 7 hours, right? Which means the claim was cannot be supported. So that was an example with data set given to you and data values given to you. If the data values are not, if the summary of the values is already given to us, then we would just go ahead and use the values that is already provided in the summary. Okay? And I also showed you the um, how to use your calculator to help you enter or obtain results by either entering the stats summaries of the stats manually or by using the data that you had already entered and pulling that in to get your uh, p-value. Okay, so I hope this was helpful. Please make sure that you look at multiple examples for different types. I will see you in the next video. Thank you.